Another beautiful day of coding, of using pytorch, and I don't know how should I. So I'm gonna watch a video on my other laptop and kind of like commentate and do the thing while I'm at it. The video is like 24 hours basically. It's a long ass video. Long ass video. PyTorch. So yeah, I need a Google collab. So I'm gonna watch this guy's video. It's a pirated course that I was able to find on. I'm not gonna say where, but you can go find it if you really want it. That he's gonna be teaching about. Let's. Mhm. So this video is for like beginners. I mean, not really beginners, but I can like post this hopefully. I need to go on GitHub really quick. Should I do a face? I think this is fuck. That's surprisingly easy. Let's go. Mr. DB. Okay. Bro, you're just gonna let it out like that? The three people are watching this actively. That's crazy. Wait, is Jupyter Notebook not Python? It is Python, right? That's a stupid fucking question. It is fucking Python, of course. Of course. Yeah, let's get into the thing. So should I be like learning? Let's just like learn deep. But what is pytorch? What are tensors? That's cool. Getting set up, introduction to tensors, matrix multiplication. Let's go to small. That's cute. Okay. Give me a second. Let me like get the camera. I think camera kind of makes it interesting instead of a sterile screen. Okay, let's focus. Can you guys see me? You guys should be able to see me now. Okay, I gotta watch an ad. Sorry, guys, I gotta watch an ad really quick. Post apocalyptic. We have the. Fuck. Yeah, I like a little post apocalyptic vibe to my room. I don't know if you guys can tell. 99 people. Should be the one. என்னம்மா? ஓகே பாய். என்ன? சரி. Error due to oversimplification. Model is underfitting. Linear model. Okay. Underfitting is when. Am I thinking those about the same thing?
Hello everyone, welcome to the channel. Today we are diving into the most important topic, that is underfitting and overfitting. I will give you the layman example so you will have the very good understanding about these two topics. So let's start with the overfitting. For example, you are my student. I ask you to prepare for the exam. You are taking the coaching from me since a long time. It's a time to test you now. So the content I have provided you to prepare for your exam, you have memorized that content, right? Now the exam day comes. You perform very well on the questions which is from your that content what I have provided you for the preparation because you memorized it. But I have added the some peak questions as well. I have added some 2 or 3 new questions, and but it is not from your out of syllabus. It is from your syllabus, but I have tweak it. So what will happen? You are not able to answer those questions. So this is also you can assume it as a new test data for you. So this is called overfit.
That's like the most retarded like way to like explain it. I'm pretty sure of that. It's basically I'm giving a model or like an ideal way of doing something, right? And when you like go above and beyond, you're just basically overfitting it. That's a good way of explaining it, right? Fuck no. I don't know if you guys saw that. It's okay though. Ooh, much more better. Fucking hell. Say it out as motherfucker. It sounds like a gradient boosted tree. What is a gradient boosted tree? There is also a component called classifier chains or hybrid model methods called gradient boosted classifier chains. I'll also explain the possibility so you can pick up the correct one. Gradient boosted. The base idea. The gradient boosting is an ensemble machine learning technique where models are built one after the other and each model fixes the error of the previous one. Most commonly, the models are decision trees, gradient boosted trees. Popular implementation, psych, what psych, scalon build models, gradient boosted decision trees, gradient boosted decision trees, gradient boosted trees. Okay, classified chains. Oh, I just wanna gradient boosted classified chains. What the what are these, bro? Oh, it's just like basic trees, is it? Theory overlap question. How does the structure of DSA binary tree compare to the machine learning decision tree? Explain the similarities of null children. Okay, do I let's look at this. I've learned some of these. Light DSA. I mean, I'm doing that. I am actively doing that. Wait, Q is used for DSA. I didn't know that. Fuck's sake. Let's look at Q is actually is pretty important for Q's backtracking and graphs are pretty important for machine learning. Same like trees and tries. DP and 2DP. Okay. Core machine learning before deep learning. Linear regression, of course. Yeah. This is like the step 7. What the fuck? Diffusion model. Okay. I started like fucking around with these ones. That is like practical deep learning. Choose one. PyTorch recommended. Okay. Deep learning fundamentals. Yeah, we're not doing that. We ain't doing that, bro. I mean, this is like one way of doing it. Transformers, yeah. I was trying to like build a Transformers from scratch, and CNN building all of this from scratch is just like too much. I think I should be able to do all of the deep learning fundamentals, obviously. That's, I think this is kind of easy. Core machine learning before deep learning. Yeah, we'll do some DSA pertaining to how is it looking. I'm gonna do trees, heaps. I'm gonna do some easy trees. Easy this one. What else? Or today though. Today I gotta do it today. Write it down. Gotta write it down. Fuck, where's my? So I gotta do trees. And the whole time I should be looking for like overlap between trees and this thing, which is nice, but it's so fucking difficult. Oh my god. Oh my god, it's difficult. I mean, what you need, Google it, go down a rabbit hole, resurface, and I guess you'll on the other side. I've learned some. I need to like text this fucking idiot. I need to. Okay. I'm gonna do this today though, so I'm gonna. I've done some of these. It's yeah. I need to do trees and graphs. Basic stuff. Let's look at the thing. Yeah, trees, backtracking, and graphs. I need to like go in that order, just like learn that and what it really means. I'm gonna do it today, matter of fact. Just a basic, easy question and all of that. Just to get like a do all of the easy questions. I'm pretty sure I can do all of the easy ones. Lead code 250 over there, but it is what it is. Wait, what? Okay, structured data. We got all of these. Wait, what? I wanna like type question. So we have transformer networks, generative networks, GNA. Okay, generated new data has new generation, discrimination, image generation. Okay, okay. This is like the oh fuck. GNA generative adversarial network. Auto encoders. Encoders is basically turning some data into a cluster of things that is a little bit difficult to like read or whatever, and encoding it again, decoding and encoding it. Convolutional neural network. Yeah, I think yeah. Image. Yeah, and graph neural network, social network recommendation systems, fraud detection. Okay, what is this? Yeah, short answer is yes. It's unstructured data. Yeah, with like structured data, you use a little bit more like a data science type of approach. With unstructured data, you use all of these like neural networks, convolutional, whatever, GNA. What else? FFN, CNN, RNN, sequence. Okay, RNN. What is NLP then? Is NLP not in the? Okay. Alright, you can help me with that. Come on. I was just joking anyway. Let's keep going. I'm gonna fuck you up. Keep going. It is a field of category of tasks involving human language, semantic and sentiment analysis, or one method used in natural language processing. Is a field of category of task involving summarization. NN, neural networks, question mark. Natural language processing, NLP. Let's break it down carefully. You're asking about the classic machine learning algorithms, random forest. Okay. Explain what each and how it works, and unstructured data is tricky. Random forest assembles a decision tree. How does it actually look? Yeah, this is DSA. I'm pretty sure that's like a leak code on this one.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve delete nodes and return forest. A pretty good problem, I think, actually. So we're given a binary tree that looks like this. Every value is going to be unique. It's not necessarily a binary search tree. There's not necessarily any sorted property, but within
Should I do this? Should I do this? I think I should do this. I mean, we're not even like, okay. Fuck you. Should I just jump into it? Yeah, it's gonna take some time. How long have I been streaming? Okay, let's just jump into it. Given, okay, can I? It's a sliding window problem. Have I done this before? Probably not. 219 sliding window. Fuck you. Pretty sure I've found, okay. Given an integer nums, given an integer nums and an integer k, return the true if two distinct. What? I need to return true. How is this going to teach me? I think I know how to do it. So nums, if it has three duplicates, if it's a duplicate within the range of one, so I'm going to use a sliding window type. And it's going, so if, fuck you. How do I do it?
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem contains duplicate 2. We're given an integer array of nums and an integer k. We want to return true if there are two distinct indices I and j such that the two values at those indices are equal and the absolute value difference between those indices is less than or equal to k. Now, the most important thing to recognize here is that by this statement, they mean that the size of the window between the two elements is less than or equal to k. So take the first example. We have 1, 2, 3, 1. Clearly, we do have some duplicate values here, 1 and 1. They are at different indices. And the question is the size of the window less than or equal to k? Well, not exactly, actually. That's another edge case that you have to keep track of. When we have I and j pointing at the same value here, what's the size of this window? Well, it's 1. There's just a single element. But what's the absolute value of the difference between those two indices? 0 minus 0, that's going to equal 0. So this equation is off by 1. Now, what about this window from 0 all the way to 3? It's, of course, of size 4. 0, 3, it would have equaled 3. And yes, it is. We find a valid window of size k plus 1 such that this problem, well, let's assume our k value in this case, instead of being 3, it was actually 1. In that case, we would want windows of size 2. What would be the brute force way to solve this problem? Well, just check every single window. Check doing that for every window. What's the easiest way to identify duplicates? Usually a hash set or a hash map is pretty easy because we can insert and look up values in constant time. There's one slight improvement here that we can make though. Instead of brute force checking every value in this window and then restarting over here and checking every value in this window and then restarting over here, checking every value here, we can use the sliding window technique, which if you're familiar with it, it's pretty obvious that it can be applied to this problem because this whole problem is about windows. So we would start our window like this. We have 1 and 2. And then when we shift our window over here, we keep this value in the window, but we would remove this from our window and add this value to our window and check, are there any duplicates here now? And we would keep doing values in which it's never the hash state anymore. Applies our window. We're going to have, and we're also going to have looping here. We're going to go through every position in the input array nums. For every value at index r, we shift. We don't want our window to be greater than the, I think it was k plus 1. So before we even do this, it's important.
Why? Some
How's it going, guys? Today we're going to be going over a question called contains duplicate 2, and this is a question that's commonly asked by Google on LeetCode. So the problem description says, given an array of integers and an integer k, find out whether there are two distinct indices I and j.
we are Charlie Cook, we carry the flame.
Okay, guys. Solve 217 contains duplicate. So we are given an integer array.
Fuck you. So embarrassing. So what is happening? So window is equal to set for I in the, okay, it's going to iterate how much ever long. If I is bigger than k, window set dot remove. Oh my god. Dot remove. What do you mean dot remove? Remove this number. Minus 1. K minus 1.
One, here we output true, because here at index 2 we have a 1, and index 3 we have a 1. And example 3, we have the following input nums and k is 2. Here we output false because no number is equal to another number within a distance of 2 indices. So here we have 1 at 0, and we have a 1 at 3, and same with 2, 2, 3, 3. They're all further than a distance of 2 indices. Okay, like always, we're going to begin with examples. So say I have the following example over here, 1, 2, 3, 4, 1, 1, and k equals 3. Now, if I were just to iterate through this array, the first number I come across is 1, and this is at index 0. So I want to go ahead and store this in a dictionary. So I see 1 at index 0. The next number I come across is 2. I don't see a key of 2 in here, so I'm going to go ahead and add it in with its corresponding index of 1. And same thing for 3. It's not in here already, so I'm going to go ahead and add it in, and its corresponding index. And 4 we spot at index 3. Now I come across a 1 over here. I see that it's already in my dictionary, so I've seen this number before. Now where have I seen it? I've seen it at index 0, and my current index is index 4. So 4 minus 0 is 4, and that's greater than the k. So this is not going to work. We can't return true just yet. Instead, what we want to do is update the index we've seen this one on. Instead of 0, now the most recent time we've seen 1 is our current index, which is 4. And we're making this update because now if we were to see a 1 again in the future, we now have a closer index for it. So now once I do come across this one over here, it's at index 5. I see 1 is in my dictionary, and I've last seen it at index 4. Because I made this update, it was no longer 0, it's now 4. And I subtract.
5 minus 4 is 1, and 1 is less than equal to k, so I would now return true. And that is all there is to it. If I go through all of this without returning true, then I never found anything within a distance of k, so I would return false. So we're going to go ahead and code this up and then run through an example. So to code this up, the first thing we're going to do is define a dictionary. Let's call this D. And we want to loop through in nums. So for I in range, length of nums, we want to check if nums of I is in the dictionary. So if nums of I in D and what we have at that key, so D of nums of I. So if the index that I am on currently, so if I minus this is less than equal to k, we return true. We found something that is the same number as us within k indices. If that is not the case, we're going to go ahead and add our index to dictionary. So D of nums of I is going to equal I. And if it's there already in the dictionary, it's just going to update the element. If it's not there, it's going to add it in. In the end, if we go through this entire for loop without returning true, then we never found anything, and all we do is return false. So let's go ahead and submit this. And it is accepted. Now, before leaving, let's just do a super quick walkthrough. Say we have example 2.
Bro, that's like the worst explanation of all time. We're using a set. That's like a really bad explanation, and it, fuck's sake. How do they fucking hire these people, bro? They're so fucking stupid. So we have, what is this method even called? It's determine if any duplicate element with a distance of k for each uses a sliding window. What is this method called? Is it called okay, there's a fixed sliding window. Okay, I'm gonna eat something and come back stronger. Fuck, what happened? Why didn't you guys tell me you can see me? That's crazy. So you guys didn't see me the whole time? Oh, this guy, bro. This guy is. I'm looking for that WhatsApp video, man. See, this is what it is. Fuck you. All you get all love. Fuck you.